Okay, this is problem 417 or problem 17 from chapter 4 in CFIN7. It's a present value of annuity. We're going to do it with payments at the end of the month and payments at the beginning of the month. And we're going to use the PV function, and then we're going to use the NPV function. So multiple ways to do these. You could actually do it by hand in here as well. The easiest is probably the PV function. So equals, sorry, let me read the question. Rebecca would like to set up an account to supplement her parents' retirement income for the next 15 years. If the account earns 7.2% compounded monthly, how much will Rebecca have to deposit today so that her parents are paid $150 at the end of each month? So equals plus will work as well. PV, open paren, so rate is 7.2%, but we got to make it a monthly rate, so we divide by 12, comma, and then number of periods is so 15 years monthly, so it's 15 times 12, and then comma, payment is the $150, and then future value, default value here is 0, so but we can go ahead and enter it. And then frequency, also default is end of the period or 1 for beginning. So here we can enter a 0. We don't have to, but anyway, $16,482 would be the cost if the payments are made at the end of the month. We can also calculate this by just multiplying this by 1 plus the monthly rate. So that would be equals times, that's a star, 1 plus 0.072 divided by 12, and we get $16,581. I can also copy this over. I need to copy from here, I can't drag it over unless I lock the references. But anyway, so Control C and enter, then Control V. So it's going to be the same number, but if I change this to a 1, I get payments at the beginning of the period, and I get my $16,581.57. So I've entered all the payments here, all the way up to 180 payments. So that 15 years monthly is 15 times 12 or 180. So the equals NPV. That's the net present value function. So first thing is the rate. So we got to make it a monthly rate, divide by 12, comma. Now we pick up all our values. So kind of a pain when you have 180 values, but so anyway, so up here, so $16,482.67, which is exactly what we got before. So now we can just let's make our rate absolute, function F4, and then we can drag this across and pick up these values. So now we're not picking up this last value, so we need to add back the very first value, because the payments are now at the beginning of the month, and we get our $16,581.57. I just moved this $150 to the beginning of the month. The beginning of the month and the end of the month are basically the same thing. So the last payment in this case is 0. So That's our calculation for end of month and beginning of month. So the correct cost her $16,482.67. If the payments are made at the end of the month, $16,581.57. If the payments are made at the beginning of the month.